Let's address the issue of troubleshooting electrical interference affecting your prototype equipment. Given the history of similar problems at another location and the suspicion that the electricity supply is the culprit, despite ruling out other factors, here's a systematic approach you can take, focusing on practical steps and readily available equipment. Since you have access to an oscilloscope, that's our primary tool. First, establish a baseline. Use the oscilloscope to measure the electrical signal at a known good location. This could be in a different building, or ideally, on a different circuit within the same building that is known to be stable and reliable. What we are looking for here is a reference point. Record the waveform you observe on the oscilloscope screen. Pay close attention to the frequency of the signal, which should be 60 Hz in North America, and other relevant parameters like the voltage amplitude. Note any irregularities you see, even in the good location, as this provides context. Next, measure the signal at the equipment in question. Connect the oscilloscope to the power input of the equipment that is experiencing the problem. Compare the measured signal to the baseline that you established in the first step. Look for any significant differences or anomalies in the waveform. Is the frequency unstable? Is the amplitude fluctuating more than it did in the baseline measurement? Are there unexpected spikes or dips in the voltage? All these are indicators of potential electrical interference. Identify potential interference sources. Look around the location of the equipment for any nearby electrical equipment or devices that could be generating electromagnetic interference, EMI. Consider the proximity of the equipment to things like power lines, transformers, large motors, variable frequency drives, welders, or even high-intensity lighting systems. These are common sources of electrical noise that can contaminate your power supply. Isolate suspected sources to pinpoint the problem. This is where you put on your detective hat. Temporarily power down or disconnect potential interference sources one at a time. After each isolation step, carefully observe the equipment signal on the oscilloscope. Watch to see if the anomalies you observe disappear or lessen when a particular device is disconnected. This will help you identify the specific source or sources of the electrical interference. Let's consider some additional considerations. Grounding and shielding are extremely important when dealing with EMI. Ensure that the equipment is properly grounded according to the manufacturer's instructions and any relevant electrical codes. Verify that all grounding connections are secure and free of corrosion. Shielding involves using conductive materials to block electromagnetic fields. Make sure the equipment's chassis is properly shielded and consider using shielded cables for power and data connections. Another important factor is power supply quality. Check the voltage and frequency stability of the power supply feeding the equipment. Use a multimeter to measure the voltage at the outlet and compare it to the equipment's required voltage rating. Also, monitor the voltage over time to check for any fluctuations or voltage sags. You might consider using a voltage regulator or an uninterruptible power supply, UPS, to provide cleaner, more stable power to the equipment. A UPS not only provides battery backup in case of a power outage, but also filters out some electrical noise and stabilizes the voltage. Software and firmware might have an impact. While you stated it's been ruled out, verify that the equipment software and firmware are up to date. Outdated software can sometimes be more susceptible to electrical noise or might not handle voltage fluctuations properly. Keep in mind external factors such as temperature, humidity, or vibration. Check for environmental factors that could affect electrical performance. Extreme temperatures, high humidity, or excessive vibration can all cause problems with electronic equipment. Now, if you can obtain additional equipment, here are some advanced techniques that can be implemented. A spectrum analyzer could be helpful. If you can get access to a spectrum analyzer, it can help you identify the specific frequency components of the interference. This allows you to track the source of the interference. An EMI measurement probe can be helpful too. An EMI measurement probe allows you to measure the strength and source of EMI directly. A data logger is another option. A data logger is useful because it can record electrical signals over time and capture intermittent or transient interference. Here are some additional tips. Consult with a qualified electrician or electrical engineer for professional assistance. They have the expertise and equipment to diagnose and resolve complex electrical problems. Seek support from the equipment manufacturer or software developers. They may have specific recommendations or troubleshooting procedures for dealing with electrical interference. Document all measurements and observations thoroughly. This will be helpful for further analysis and for communicating the problem to others.